Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Birch reduction involves dissolving metal reduction, now only in liquid NH3 with an alcohol as proton source, of aromatic rings. The redoselectivity depends on whether the substituent is electron donating or electron withdrawing. Moving on to the next step. Electron withdrawing groups, EWG. The double bonds remain conjugated with the EWG in the product. Reduction occurs at the unsubstituted positions. IChO and para to the substituent are reduced, leaving double bonds that include the carbon bearing the EWG. In other words, for EWGs, the unreduced double bonds are those conjugated with the group. Electron donating groups, EDG. The double bonds remain on the unsubstituted carbons. The substituted carbon gets reduced. Moving on to the next step. ChO is an electron withdrawing group. And for the final step. For an EWG like ChO, Birch reduction leaves the double bonds in conjugation with the ChO group. The product retains double bonds at C1, C2 and C5, C6, i.e., the positions adjacent to and including the carbon-bearing ChO, giving 2,5-cyclohexadiene 1-carboxylic acid. Specifically, the product is 1-carboxyl 2,5-cyclohexadiene, where the ChO-bearing carbon, C1, is part of a double bond, C1 is equal to C2, and another double bond is at C5 is equal to C6, leaving C3 and C4 as the sp3, reduced carbons. Option A shows a cyclohexadiene ring with ChO where the double bonds are positioned such that they include the carbon-bearing ChO, conjugated arrangement consistent with EWG rule. This corresponds to 2,5-cyclohexadiene 1-carboxylic acid, the known Birch reduction product of benzoic acid. Option B. Fully saturated cyclohexane with ChO. Birch reduction only partially reduces the ring, adds to H, leaves to double bonds, not full saturation. Option C. Double bonds conjugated but in a 1,3-diene pattern adjacent to ChO. This would be the EDG product pattern, not EWG. Option D. Similar unconjugated pattern, but structural arrangement does not match the known product. Option A is the established correct regiochemistry. Therefore, the correct answer is A. Therefore, the correct answer is option A.